Statistics for Business Introduction, Chapter 1. In this video, we're going to take two examples and learn how we can use data to fill the gaps in understanding. Let's say you're trying to buy a BMW, a car, and you see an ad that says, hey, this is a $27,000 car. It has run for 20,000 miles. And you're trying to find out, hey, should I buy this car? Is the price too high or too low? That's where data comes in. That's where data analysis comes in. Another, we're going to find out what is going to be the future unemployment. Are the businesses going to lay off because of, let's say, COVID situation that's going on? Or let's say there was a hurricane and you want to find out what is going to be the unemployment impact. Then we're going to use those two examples and go into the depth. But there are many examples that we can use similar practices. Like let's say you find out in the news that says, hey, unemployment is going to rise by 3%. How do you make sure that what they're saying is actually true? A lot of times you'll find out that you need to validate, cross-validate, and maybe you can get ahead of the news people to make your data much more accurate. Even businesses need to decide, like, hey, should we buy a new equipment or an old equipment? Should we hire more people or should we lay off people? How do they go about making those decisions, right? Should we buy our own devices or use Amazon Cloud or Microsoft Azure, right? All of those are decisions that need to be grounded in data. So let's take a simple example. A car that you saw an ad for, BMW 328i, $27,000, 20,000 miles. So how do you go about finding out whether this is too high, too low, or this is the bargain? So the first step you do is you find out similar ads. You find out hundreds, if not tens, if not 20 such ads, and you plot in a table. What is the price and what's the mileage? What is the price, what's the mileage for all the ads? When you create this table, you get a good sense of like, hey, I have this price variable and I have this mileage variable, and there are many variables that are hidden. Like for example, some cars might have a color that might be expensive, that might have an interior that is custom made, leather, etc., interior like enhancement, sunroof, alloy wheels, and others. So there are many hidden variables. Let's simplify it for now. Two variables, price and miles. You're trying to make a very quick decision. Hey, is this person asking too high of a price or not? So once you plot various ads together, you can also look back for the last month as to what were those ads and what were they for. So then you can very quickly plot a price versus miles, like all of those data points. Once you plot those data points, you can quickly find out, hey, where is my 27,000 and 20,000 miles falling into? And you can maybe find out, hey, it's falling somewhere here. Once you plot all of these data, you can actually draw a line that, you can see a predictable trend. And this is a pattern, right? Like if you see when the miles go up, the price goes down. The miles go up, the price goes down. And that is we call a predictable pattern. You might have some outliers, but if let's say the car is total, you might get it for cheap, but then it's then you have to actually ignore it. So typically there is some pattern. If you find out a pattern, then you can actually draw a regression line, a line that basically, and there are tools that can do this for you, but at least mentally you'll be able to draw this pattern. And then you can plot where is my point for this ad fitting. And you can realize that if it's below the line, that means it's a deal, it's a bargain. But if it's above the line, that means this ad is too expensive. This car is going for too much of a price. I could maybe get another better car, right? But you may not have the same exact data points, but at least you can have a trend line that you can draw. What did we do here? We borrowed strength from data. The data told us that, hey, most likely this is cheap. Right? And so then we can say, let's go buy the car. So based on data, we were able to fill the gaps in our understanding, whether this is cheap or whether this is expensive. Let's take another example. Let's say businesses right now are trying to find out what's going to be the unemployment in the next 6 months. So then what you can do is you can plot this graph, which just says year. And then over here, it could, on the y-axis, it could be, let's say, GDP. And you can have another y-axis, which shows unemployment. So let's assume this is a GDP, and you see a blip here. And then it goes up, 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 up. Let's say this was the 1970s, and there was issues here, 1990s. There was there was a down blip, right? So now you have found out historical data, and you know that, hey, when there are these issues like 1990 or 2000, when there was a dot-com bust, or when 2008 financial crisis, and then you can plot that and then see, hey, how is unemployment, which is this axis, changing? And you might see a pattern that says, hey, unemployment goes up when there are these issues, and it has certain peaks and certain troughs. And when you do that, you can actually say, hey, if it was this issue in 2008 and it caused this big of a problem, what would it be for unemployment? We're already seeing unemployment numbers go up much more higher, close to 14 to 16 million in the United States alone are unemployed. So then you can see like what those patterns are and what causes them to go down. It's much easier to do this, let's say, on hurricanes, right? Like, let's say there was a past hurricane and you wanted to find out what was the impact. Similar patterns you can draw, and then you can postulate with some degree as to what my future is going to look like. Because then you can have a trend line again that you can draw that says, hey, it can have a blip, but then the blip is actually is temporary. Like the moving averages. Moving averages are a good one. If it goes down, it doesn't go down instantly. It goes down slowly and goes up slowly. But there's that pattern that you can draw to predict with some level of confidence as to, hey, typically it takes this long for it to recover, or this is the anticipated impact for unemployment. So now what we did, we looked at history to predict the future. Is this bulletproof? I would say no, but at least it's roughly in the ballpark. Every hurricane is different. Every crisis is different. You can't compare the Great Recession with today, although today the unemployment number is much higher. But you can see that it impacts certain sectors like travel and leisure so much more than, let's say, technology, which is like an all-time high. Apple just last week hit $2 trillion. That's more than, I think, the economy of United Kingdom or something, like big country. So it's very specific. You can't, there are a lot of caveats you need to draw. Similarly, there's lots of errors possible when you're trying to predict the future, but at least you have some sense. The best you can get is some sense of like, hey, what is the probability of this being accurate, and which we'll get into the next few chapters. So we looked at two different examples, and I gave you a few more examples. Like when someone says something in the news, don't just take it for granted. Do your homework. If they're talking about unemployment, look at non-farm unemployment payroll numbers, and then see how it has trended. See during various situations in the past, what was it like? Draw some sort of a pattern through it, and then make your own judgment. Get better at looking at the data. You can also do this for your company when you're trying to find out, hey, is my company under financial stress? Are they going to lay off people? Well, you look at how the company did. Find out like how is your company performing financially? How many people you have? What is going on in terms of productivity, sales, and a whole host of other things. You can get really good at this, but how good you can get at it, it's up to you. But the data is very powerful. Once you have the data, you can actually see trends and you can borrow strength from it to get a likelihood of what's going to happen. And there's a probability, which we will cover in the next few chapters. So when you see some sort of a pattern, that's an important concept. When there's a predictable feature in a data, we call it a pattern, right? There's a predictable downward trend. When the miles go up, cost goes down, right? Similarly, there's blips of unemployment when there are issues. The GDP and unemployment numbers, there's this correlation in some sense. So that is helpful for us to know. But again, remember, there's this thing called error, right? And variation. The variation of data here is like, this kind of data we've not seen at all, like the unemployment numbers. Similarly, if your systems uses past historical data and the trend it uses, let's say an airline today is trying to overbook tickets, but it's doing that based on patterns of the past. But guess what? COVID actually makes all of those data and all of those models not work, because they would have never thought that they'd never be able to oversell. Forget about like overbidding, the price going up, and all of that. So remember that those caveats is important. Remember there are issues of variation in data, situations that are very different that you have to factor into what is going on, and make your judgments and adapt your systems and processes But hopefully this is a very exciting introduction, because it gives us so much capabilities. If we can predict so many of these things, if we can borrow strength, if we can use our data. That's why all of these big companies, all of the big companies, the data is the gold mine. Why? Because the data gives you information to make decisions. Remember the book, the title of the book was To Make Effective Decisions in Analysis, right? Effective decisions and analysis. And so if you want to make effective decisions and analysis, you need powerful data. You need up-to-date data. A lot of big companies, even in India, right, like Asian Paints, Bajaj Finance, they use so much data. They use the power of technology, Microsoft, Amazon, Facebook, a whole host of companies. They are powerful because they have data. They have data that they use to their benefit. So it's very important to use, for all of us to understand how we benefit from it. How do we make sure that we understand how to find out patterns? How do we find out if there are variations? And how do we not go too overboard, because all of this can be, it's just probabilistic. It can be wrong as well. So understanding and getting better is very, very important when it comes to data analysis and decision making. Thank you.